looking back, looking forward, looking down, looking up, looking around. Come, join a journey of exploration to the distant past, to the frontiers of tomorrow, from the infinitely small to the infinitely large, the mysterious, the mundane. Come, let us travel to the horizons of knowledge. This program has been made possible thanks to a generous grant from the Swiss Agency for Development and Cooperation, the Vodafone Egypt Foundation, the OPEC Fund for International Development, and the Carnegie Corporation of New York. Since the earliest times, humans have looked at the heavens with wonder. They saw patterns in time and space, in the cycles of day and night, the lunar month, and the seasons marking the solar year. Where the sun rises and sets help to mark the cardinal directions. The patterns of the stars imagined into constellations and their movements marked time, but also helped to find direction. Gradually, we learn to understand the stars and the vastness of the universe and our place in it. This is the story of the journey from observation to understanding. It is the story of astronomy. Millennia ago, the first human communities looked at the heavens with awe. Many worshipped the sun and the moon, others identified with the stars and the constellations. Early traders, whether in deserts or in seas, looked to the stars for direction, and they used the lunar cycle to mark the passage of time. Ultimately, they adopted a lunar calendar. But established agrarian societies tended to work with the seasons, and the solar year became their grand unit. But all societies looked to the heavens and tried to understand what were these bodies that were up there in the sky. Gradually, very gradually, we started to discover more and more about the vastness of the universe and the unimaginable distances it comprises, the enormity of the numbers involved, and the billions and billions of stars that exist out there. That journey started millennia ago, in China, in Mesopotamia, and here in Egypt. Ancient Egypt was a precursor in this understanding of the heavens, and early references to the stars and the constellations showed extensive knowledge, as did the accuracy of the manner in which important buildings were aligned.
The Temple of Dendera has the most important sky representation worldwide and the most ancient sky representation worldwide.
Egyptian, Greek, and Asian science, knowledge, and wisdom all came together in the formidable ancient library of Alexandria. And it is from Alexandria that the first human voice, that of Aristarchus of Samos, rose to say that the earth revolves around the sun, not the other way around. Hipparchus set down the first complete atlas of the stars and calculated the length of the solar year 365 days, 5 hours, 55 minutes, and 12 seconds. Our modern estimates are 365 days, 5 hours, 49 minutes, and 19 seconds. So he got it right to within 6 minutes. Awesome. Eratosthenes proved that the Earth was spherical. He also calculated the distance between the Sun and the Earth to be about 80% of our current estimate, and calculated its circumference to 98.5% accuracy. And he actually calculated the correct inclination of the Earth's axis at close to 23.44 degrees. Awesome achievements with minimal instruments. Hypatia, last great scientist of ancient Alexandria and first martyr to science, was a specialist in the calculation for the design of astrolabes.
But it was Claudius Ptolemy, another astronomer in ancient Alexandria, who would restore the Earth to the center of the universe, a view that would prevail till the 16th century. Ptolemy's magisterial grand synthesis, best known by the Arabic title the Almagest, was to dominate all astronomy for over 1,000 years.
The Muslims and Arabs would carry the torch throughout the Middle Ages. They scanned the heavens and named the stars. Here are some of the constellations. In the 11th century, Ibn al-Haytham promoted experimental science and pushed for a separate celestial mechanics.
And Omar Khayyam, famous for his poetry, his rubaiyat, was also a most distinguished mathematician and astronomer. Khayyam calculated the length of the solar year to an accuracy of many decimal places, and is said to have performed calculations for an improved calendar almost as precise as the Gregorian calendar.
In the 12th century, Fakhr ad-Din al-Razi criticized the idea of the Earth's centrality within the universe, and instead argued that there are more than 1,000 worlds beyond this world. In the 13th century, the glory of the Abbasids would fall to the advancing Mongols. Hulagu would burn Baghdad to the ground, and it seemed that science would suffer a major setback. But Nasir ad-Din al-Tusi would manage to convince Hulagu, the destroyer of Baghdad, to found the Maraga School and Observatory, which would remain one of the most important centers of astronomy for centuries.
الطوسي أتى بنظرية أخرى تسمى الآن مزدوجة الطوسي، وهي منتهى الأهمية لأنها رمية من غير رام. استعملها، لم يستخدمها فقط كوبرنيكوس، استخدمها غاليليو، واستخدمت أخيرا أيضا في تحويل أي حركة خطية إلى حركة دائرية التي نستعملها في إنتاج السيارات إلى الآن. بمعنى أنه
يعني البيستون بتاع العربية لما بيضرب كده ويحرك
العجل بشكل دائري.
نقل الحركة دي من هذه لهذه ده جزء من
هذا جزء من تطبيق نظرية الطوسي.
Ibn al-Shatir developed powerful mathematical insights that impugned the Ptolemaic system and helped lay the groundwork for the Copernican revolution. In 1543, Nicholas Copernicus would help usher in the modern scientific revolution by developing a heliocentric system where the planets revolved around the sun. His book, published while he was on his deathbed, would be overtaken by another book of great importance. Galileo almost lost his life defending these views as they contradicted the prevailing church dogma. But it was in 1609, with Galileo, that modern astronomy begins. Galileo was the first to scan the heavens with a telescope. Here is a replica of his telescope at the Smithsonian in Washington, D.C. 400 years ago, Galileo took a telescope composed of a tube with two lenses and turned it towards the heavens. And this was the first time that humans observed the heavens with an instrument. Here
is the facsimile of Galileo's instrument.
Newton would invent the mirror telescope, and that is the design still used to this day.
By 1668, Isaac Newton elaborated a new kind of telescope that relied on mirrors. And here is a replica of Newton's telescope.
A significant improvement was the Cassegrain telescope, which built on Newton's mirror telescope but used parabolic and hyperbolic mirrors for better focusing. With all this additional observation, by Newton's time, the issue of the heliocentric system was largely accepted in the scientific community, and Newton's own contributions would finally resolve all doubts, church opposition notwithstanding. But let us back off a few years. Tycho Brahe, a fascinating Dutch nobleman who had lost his nose in a duel and wore an artificial nose, had amassed some excellent empirical observations. Johannes Kepler was Tycho Brahe's assistant. Kepler was to become one of the most distinguished figures in astronomy. He used the enormous mass of data that Tycho Brahe had amassed and showed that if Copernican system was modified to use ellipses rather than circles for the orbit of the planets, the data would support Copernicus. Furthermore, Kepler developed his three planetary laws. First, that the orbits of the planets are ellipses with the Sun at one of the foci. That the time of rotation around the Sun squared is proportional to the distance from the Sun cubed. And third, the orbital speed of the planet changes around the orbit, accelerating when it is closest to the Sun, but sweeping out equal areas in equal times. Enter Isaac Newton. Born on the year of Galileo's death, Newton would construct the greatest scientific edifice the world had ever known. How did Newton discover the law of gravitation? Actually, it was not quite by having an apple fall on his head. Rather, it was by watching a low-hanging apple fall to the ground. He then asked himself if the force that pulled the apple to the ground was the same that would go higher and pull another apple on a higher branch, and pull that one also to the ground. And if that force could reach that far, did it reach all the way up to the moon? And if so, why did not the moon fall to the ground? That reasoning led Newton to what I consider to be three great insights about gravity. The first of the three great insights is an understanding that gravity is a reach that extends from the Earth to the moon and beyond into infinity. The second is that the moon is actually falling towards the Earth. Its speed would normally have it move in its linear trajectory away from Earth. But the moon is at the right distance, moving at the right speed, and of the right mass, that its natural linear movement and its fall in response to the gravitational pull of the Earth keep it in orbit around the Earth. And the same is true of the planets around the Sun, given their distances and their masses and their speeds. Now, the third was a truly profound insight. Not only did the Earth pull the apple also pulled the Earth towards it. But given the difference between the masses of the Earth and the mass of the apple, we never feel the pull of the apple. But the insight is that gravity is exercised by each object towards all other objects in the universe, and that it is proportional to the product of their masses and by the inverse of the square of the distance between. With these profound insights into gravity, his three laws of motion, and his invention of the calculus, Newton could then produce the most incredible treatise the world had ever seen. His 1687 publication, Philosophia Naturalis Principia Mathematica, usually called the Principia, would link physics with astronomy and would provide a view of the cosmos that would dominate the scientific worldview of the physical universe for the next 3 centuries. Now,
Now, the next 2 centuries were years of gradual improvements in our knowledge and addition to the store of known heavenly bodies and more accurate observations of the heavens as more powerful telescopes became available.
It is important here to note the role of women in astronomy. By the late 19th and early 20th centuries, many women were hired as computers, people who do the drudgery of computing to support the work of the male astronomer. But many discoveries in this period were originally noted by the women and reported to the supervisors.
For example, at the Harvard Observatory, Henrietta Swan Leavitt discovered the Cepheid variable star period luminosity relation, which she further developed into the first method of measuring distance outside of our solar system. Annie Jump Cannon organized the stellar spectral lines according to stellar temperature, and in only 4 years discovered and catalogued more stars than all the men in history put together.
Most of these women received little or no recognition during their lives due to the prevailing bias against women and their lower professional standing in this field of astronomy.
Discoveries would accelerate as spectroscopy allowed scientists to identify the composition of the stars, and as radio waves were captured and radio astronomy became an active part of astronomy, we witnessed much more data, much more information. And the organizing principles were also revolutionized. In the early 20th century, Einstein revolutionized physics and cosmology, and a few years later, Edwin Hubble would revolutionize astronomy and give us the expanding universe. Hubble settled the issue of the existence of other galaxies, and he identified the Andromeda Nebula as a different galaxy and many others at large distances and receding, moving away from our galaxy. Hubble measured the redshift in the light of distant stars to establish that they were extremely distant and they were receding from the Earth at a rapid pace. And his empirical observations and his quantitative law helped establish the prevailing view of the expanding universe. Since then, we have not only accumulated information, we have successfully traveled to the moon. We have sent probes all over the solar system. But down here on Earth, our best telescopes are still facing obstacles. The atmosphere of the Earth is still an impediment to properly seeing the stars and the planets. And with the advent of space exploration, the idea of putting a huge telescope outside of the Earth's atmosphere became possible. Hubble Space Telescope was the result. Getting the Hubble telescope into space and getting it to function was a major feat of engineering. And the Hubble telescope was able to produce some of the most spectacular images of the heavens we have ever seen. Today, as the new International Space Station is completed and opens an era of collaborative effort by all nations to better understand the universe, astronomy enters into a new age. The Hubble Space Telescope will now be replaced by new and more powerful instruments, carrying us ever further in our quest to know more about the infinite vastness of space and the billions and billions of stars and planets that are spread throughout it. So we now know so much more about the stars and the planets. We know about the galaxies and the expanding universe. We know more about the structure of the universe and even more about what we do not know and that we would like to know. It's been an exciting journey, and it inevitably raised many questions that have challenged people from the oldest of times. Just what is the universe like, and what is our place in the cosmos? These questions are part of a field closely related to both astronomy and physics, cosmology. Bit by bit, over the centuries, we've been constructing an image of the universe and how it has unfolded. Physical cosmology made huge advances during the 20th century, with the model of the hot Big Bang some 13.7 billion years ago, being heavily supported by evidence provided by astronomy and physics. But weird things abound, from black holes to dark matter. The puzzles take us from subatomic particles to the edge of the visible universe, billions of light years away. The search for understanding the universe and our place in it, the formation of modern cosmology, is truly an exciting story. But that is a story for another day. I am Serageldin, and I thank you for having watched this program of Horizons.